Hi, welcome to Conquer the Concept, and in this video we'll be discussing about two-dimensional optimization. Optimization means getting the minimum perimeter for a fixed area or getting the maximum area for a fixed perimeter. The solution to both of these criteria would be the same. The best shape for optimization in two dimensions is a circle. After that, the shape with as many sides as possible is the best. In quadrilaterals, the square is the best because the square is the best because it is a regular polygon, meaning that it has 90-degree angles and four congruent sides. After the square, the rectangle, where the difference between the length and the width is minimum, is the best. In triangle, the equilateral triangle is the best. If you only have to enclose three sides because the fourth side is already closed, then out of the quadrilaterals, the rectangle where length is equal to twice the width is the best. Let's go to a more descriptive section of each shape. The circle, the best shape for optimization, you can find the circle's area by multiplying pi times the r squared, or r stands for the radius. A circumference is equal to twice the radius multiplied by pi, or pi times the diameter. If you're unfamiliar with the what the radius and the diameter are, the diameter is just a line passing through the center of the circle from one end to the other, as you can see on the left. And the radius is always just half the diameter. And pi is equal to 3.14, and mathematicians use it so commonly that they just assigned a symbol to it. The next shape, the square, is you can find the square's area by multiplying this one side length by itself, or squaring it. And you can find the perimeter by adding up all the sides or multiplying one side length by 4. The rectangle, you can find that by multiplying length times width, the area. You can find the area by multiplying length times width, and the perimeter by multiplying 2 times the length plus the perimeter, as you can see here. And then the equilateral triangle, you can find the area by multiplying uh square root over 4, square root 3 of square root of 3 over 4 multiplied by the side whole squared, and then the perimeter but just by multiplying 3 times the side, or adding the side 3 times. In an equilateral triangle, all of the side lengths are the same, and the angle lengths are always 60 degrees. Let's work on our problem. The problem is, what will be the maximum area to enclose a garden with a fence of 200 feet? So, to rephrase it, it's as saying, how much area can you enclose with the perimeter of 200 feet? Because we're working on it for the first time, we can go down each list of shape, starting with the circle, until we find the best one. So, in circle, the area is equal to pi r squared, and the perimeter or circumference is equal to 2 pi r. And in this case, it's saying that we have a fixed perimeter or fence length of 200. So we would set 2 pi r is equal to 200, and we could solve this for r and find that 100. And then if you have a calculator handy, then you can do 100 divided by 3.14, the value of pi, to get r value is equal to 31.8. And you can substitute this into the pi r squared, the area formula, and get 31.8 squared times pi. So square this value, 31.8, and multiply it by 3.14, and you would get the circle area. With the circle, you would get an area of 3,184.7. So that's the area that a circle will give with a circumference of 200. And let's erase this. And let's go to a square and see how much area a square would give. So a square and a square, if the fence length is 200 feet, that means that 4 times s is equal to 200. And then we would get s is equal to 50. And then the area, to find the area of a circle, you would multiply the side length by itself. So 50 by 50 times 50, or 50 squared, is equal to 2,500. So square length is equal to 2,500, a little bit less than the circle. Okay. So we're finding we're only using the select group of shapes, and if we used a shape with more sides than the square, or 4, then we would get a higher area than this, and it would be between the circle and the square. But we're focusing on this only because of the quadrilaterals and the regular optimization. So now for the rectangle, where length is equal to twice the width, we would get, to find the perimeter of a rectangle, we would multiply 2 times L plus W, and since we know the L value is just 2W, we can substitute it, W, and then 2 times 3W, and then we can get 6W. 6W is equal to 200, and then divide 200 by 6, and then we would get 33.3. W is equal to 33.3, and since the length value is just twice of W, we get L is equal to 66.6. And to find the area of a rectangle, basically we would just multiply the length times the width. So we would multiply 66.6 times 33.3, and then we would get 2,222.2 repeating. So we can erase this. And so far we see that the circle is the best, then the rectangle, then the square, and then the rectangle. Now let's try the last shape, the equilateral triangle. Okay. So equilateral triangle. So the formula to find the perimeter of an equilateral triangle is equal to just 3 times the side length, because all the sides are the same length. So 3s is equal to 200. That means that s is equal to 66.6 repeating. So basically, and to find the area formula, I'll write it again, is square root of 3 over 4 times s squared. So we square 66.6 repeating to get 4,444 repeating, and then multiply that by the square root of 3 divided by 4 is equal to 0.433, and that multiplied by s squared would give us 1924.5. 1924.5. So we can see from our chart here that the circle is the best, then the square, then the rectangle, and then the equilateral triangle. Okay, so some other problems you may come across might specify the type of shape that you're allowed to use, saying that the person who's making the fence wants to make it in a rectangle shape. If you're ever given that problem, remember that every square is a rectangle. So just because it says rectangle shape doesn't mean you can only use the rectangle. It means you can use the square or the rectangle. Let's do a recap of what we learned today. And so this first statement says that optimization means getting the minimum perimeter for a fixed area, or vice versa, and the best shape for two-dimensional optimization in general is the circle. And after the circle, you would want as many sides as possible in the shape to maximize optimization. But when you're looking for quadrilaterals, the square is the best shape to use. And the square, after the square, you want the ratio of the uh the the difference between the length and the width, to be minimum. So the ratio of the length and the width should be as close together as possible, and that would be better than having them farther apart. And apart from quadrilaterals, the best shape in triangles is the equilateral triangle, again because it's regular. And if you only have to enclose three sides, then the out of the quadrilaterals, the rectangle where length is equal to twice the width is the best. And lastly, if you're given a problem where they say which of the rectangles is the best for optimization, then choose the square, because the square is a rectangle. If you enjoyed this video and learned something, please like and subscribe to Conquer the Concept, and leave a comment down below. Thank you.